Hello everybody, welcome back. In this video we'll be going over the next section, which is on two-way tables. Two-way tables are examples of contingency tables. So here I picked up a study from online. You can find the study at this address. So here in this study was done in 2014, and the study was on the party preference in party preference of Ohio adults. So in the study, 1,132 adults were randomly picked, and about half of them were men and about half of them were women. And the results from the study are as follows. So it turns out that 47% of men lean toward the Republican Party in Ohio in 2014, compared to 35% of men leaning toward the Democratic Party, and about 18% of men preferred none of the two parties. And the result for women was kind of the opposite. That is, 37% of women preferred the Republican Party, compared to 45% of women who preferred the Democratic Party, and about 18% of women didn't like any of the two, or I should say didn't prefer or didn't lean toward any of the two parties. So in this study, what are the variables of interest? Well, there are two variables that we are looking at here. One of them is gender, and the other one is party preference or party affiliation. So this study, we can express that in a table, and here is the table for the study. This is a table of counts or frequencies. So let's make sure this is called a two-way table. So a two-way table is a way for us to study the relationship between two categorical variables. So here I have two categorical variables. One of them is gender, the other one is party preference or affiliation. So gender has two values, men and women, and party has three values, either lean Republican, lean Democratic Party, and lean no lean. That is no preference here. So in the study, 1,132 adults were picked in Ohio in 2014. So they were picked randomly. So 1,132 adults were picked randomly, and it turned out that 533 of them were men, 599 of them were women. So now, if you look at the numbers in each of these cells, they are counts for those cells. That is, so what is 250 here? 250. So among the 1,132 adults, 250 of them were men, and they leaned the Republican Party. 221 of the adults picked were women, and they leaned the Republican Party. And this is so I have also added the total here. So this is the 471 is the total number of adults who leaned the Republican Party. And then if you look at 95, that means this number is the count of men who did not lean toward any of the parties, and 107 is the count of women, or the frequency of women who did not lean toward any of the parties. So among all the adults, 202 of them did not lean toward any of the parties. 188 of the adults were men and leaned toward the Democratic Party. 271 adults were women and who leaned toward the Democratic Party, and there was a total of 459 adults who leaned toward the Democratic Party. So 459, that's the total count of adults leaning toward the Democratic Party. 471 is the total number of total count of adults leaning toward the Republican Party. Okay, so I hope you understand what the numbers in the table represent. So these numbers again are called counts or frequencies. So when we are studying the relationship between two categorical variables by using a two-way table, the variables, both of the variables, must be measured on the same cases or units, that is, on the same individuals. Okay, so the same table that I have drawn here, we can also so here I have the gender so we have the variable gender written on columns here, and the variable party preference is on the on rows. But we could do the opposite. So we have gender represented by the rows and the party preference represented by the columns. So we could have done, so instead of making this table, we could have made this table right here. So the only difference is we are switching the two variables. So again, in the first table, gender was represented by the columns and party was represented by the rows. Here it's the opposite. Okay, so now I want to ask you the following question. So we know that the total number of adults the total number of adults in the study was 1,132. So among all these adults, what is the proportion of adults who are men and lean the Republican Party? So how do I find this? How do I answer this question? Well, notice that among all the adults that were picked, 250 of them were men and 250 of them were men, and they preferred the Republican Party. So the proportion of adults who were men and leaned toward the Republican Party would be given by 250 divided by the total count of the adults. So 250 divided by 1,132, that's about 0.22. So this is the proportion of adults who are men and lean toward the Republican Party. Now, as a percentage, this is 22%. That is 22% So if you multiply this number by 100, you get the percent, and 22% of the adults were men and leaned toward the Republican Party. So what I'm going to do now is divide the count of each cell, divide the count in each cell by the total number of adults. And that's going to give me the proportion for each of the cells. So here's what I get. These are all the proportions now. So this table is known as the joint distribution of the two variables. So here, so if you look at the 0.22, that's the proportion of adults who are men and preferred the Republican Party. 0.20, that's the proportion of adults who are women and preferred the Republican Party. And similarly, the other numbers. So these numbers are also called the relative frequencies or proportions. Now, if we multiply each of these numbers by 100, then we get the percents. So basically, when I multiply all these numbers by 100, this is the table that I get. So this is telling me that 22% of the adults were men and they preferred the Republican Party. 20% of the adults were women who preferred the Republican Party. 23.9% of the adults were women and preferred the Democratic Party. Okay, so these percents give us a little bit of a better idea about on the relationship between the two variables. So one thing you can notice here is that men tend to prefer the Republican Party more than women, and women tend to prefer the Democratic Party. Women tend to prefer the Democratic Party over the Republican Party. So this is the case. This was the case in 2014. Okay, so what I want to look at now, it would be so this table is known as the joint distribution, right? So if I ask you, hey, if I randomly pick an adult in Ohio, what's the chance that the adult will prefer the Republican Party? Well, my answer would be that the chance is 22% that the adult will prefer the Republican Party. So again, if I pick an adult in Ohio randomly, if I pick a man, an adult man in Ohio, randomly, and then I ask, what's the chance that that person prefers the Republican Party? Well, that would be 22%. What is the chance that a female adult will prefer the Republican Party? Well, that's 20%. What's the chance that a female adult will prefer the Democratic Party? Well, that's 23.9%. Okay, now I want to look at the marginal distribution. So recall that this is the table that we started with. So this is the table we obtained from the study, and in the last column here and the last row here, I have the total the last column gives us the total of each row, and the last row gives us the total of each column. So basically, among all the adults that were picked, so remember we picked a total of 1,132 adults. Among all those adults, 533 of them were men, 599 of them were women, and also among all the adults, 471 of them preferred the Republican Party. 202 of them did not lean toward any of the two parties. 459 of them 459 of them preferred the Democratic Party. So what is the marginal distribution of gender? So each variable has an associated marginal distribution. So what do we mean by the marginal distribution of the variable gender? Well, among all the adults, what is the proportion of adults who are men, and what is the proportion of adults who are women? So gender, the variable gender has two values, men and women. So we want to know what is the proportion of adults who were men, and what is the proportion of adults who were women? Well, to answer that, we just look at what's the total count of men. The total count of men is 533. We divide that by total number of adults. That's 0.471. And the total count of women is 599. And then we divide that by 1,132. We get 0.529. So these are the so these two numbers here, they give us the marginal distribution of the variable gender. So I'm going to go ahead and put these proportions in the table. That is, all the numbers in the number in each cell will be divided by the total number. So okay, so before I do that, here's another what is the marginal distribution of party affiliation? Party affiliation has three values, so you need to find the proportion for each of the values. So among all the adults, what's the proportion of adults in each category of party affiliation? So what proportion of adults leaned toward the Republican Party? Well, 471 of them. So 471 divided by 1132, that's 0.42. What proportion of the adults had no lean? Well, 202 of them. So 202 over 1,132, that's 0.8. And what proportion of the adults lean toward the Democratic Party? Well, that's 459 over 1132. That's 0.405. So these are the marginal distribution. These three numbers give us the marginal distribution of the variable party affiliation. So now in this table, I wrote down the proportion for each of the cells, and the last column gives us the marginal distribution of the variable party affiliation, and the last row give us the marginal distribution of the variable gender. Now, if I convert all these numbers to percents, this is what I get. And so again, the last column gives us the marginal distribution of the variable party, and the last row gives us the marginal distribution of the variable gender. Now, so again, so if you look at the last column, right? So what's the meaning of 42% in the first cell of the last column? Well, it means that 42% of the adults that were picked in this study, so 42% of the adults in this study preferred the Republican Party. 40.5% of the adults in the study preferred the Democratic Party, and 18% of the adults did not lean toward any of the two parties. The last row, the percents in the last row, what are they telling us? Well, 47.1% of the adults in the study were men, and 52.9% of the adults in the study were women. Okay, so the last thing, another kind of distribution that I'm going to look at now is called the conditional distribution. So so we want to know the distribution of the so the first thing I want to know is the count of the adults on the with the conditioned on the gender value equal to men. So conditioned on gender value equal to men. So now basically we are from our study we are getting rid of all the women. So then we have a total of 533 men. So because we are conditioning on gender equal to men, so basically here's what we are asking. Among all the men, what's the count of for each of the party values, right? Among all the men, what is the count of so let me rephrase that. What count of men preferred the Republican Party? What count of men preferred the Democratic Party, and what count of men did not lean toward any of the two parties? So here I have 200 and so we have a total of 533 men. Among them, 250 of them preferred the Republican Party, 95 had no lean, and 188 leaned toward the Democratic Party. So the value, the count for women in each of these categories for party is 0 now, because we are conditioning on the gender value equal to men. So because we are only looking at the men adults, the count for women will be all zeros now. So now if I now look at on this condition, right, what's the proportion or percent of each of the count here? So 250, so total number of men is 533. Among them, 250 preferred the Republican Party, right? So 250 divided by 533 multiplied by 100, that's 46.9. So this is the percent of men who preferred the Republican Party. And then 95 divided by 533, that's 17.8%. That's that 17.8% of the men had no lean. And then the 35.3%, that is 188 divided by 533, that's 35.3. 35.3% of men preferred the Democratic Party. And of course, the percentages for women in each of these categories would be 0. So this is known as, this table here, the second table here, is known as the conditional distribution of the conditional. So this is known as the distribution of the variable party conditioned on the gender value equal to men. Again, this is the conditional distribution of the variable party conditioned on the gender value equal to men. So for each of the, so we can make another conditional distribution conditioned on gender value women as well, which I'm not going to do. But we can also condition on we can also look at the conditional distribution of gender conditioned on the party values. So I'm going to do an example of that. So here again I'm now conditioning on party equal to the Republican Party. So that means the count for no lean and lean Democratic Party will be 0. Okay, so the count for each of the cells corresponding to the party value no lean would be 0. Counts for counts for each of the cells corresponding to the party value. Lean Democratic Party would be 0. So the count, so you only keep the count for the Republican Party. So here what we have that among all the adults that were picked, a total of 471 of them preferred the Republican Party, where 250 of them were men and 221 of them were women. So now I divide 250 by 471, divide 221 by 471. And if we do that, we get 53.1% and 46.9%. So I'm missing, I should be writing 100 here. So basically what we are getting then is that 53.1% of the adults who leaned toward the Republican Party were men. Okay, let me say it this way. Among all the adults who leaned toward the Republican Party, among all the adults who leaned toward the Republican Party, 53.1% of them were men and 46.9% of them were women. So these numbers give us the conditional distribution of the variable gender conditioned on the party value being the Republican Party. So let me ask a question in the following format. Given that an adult prefers the Republican Party, what's the chance that the adult is a man? Well, the chance that the adult is a man is 53.1%. So again, given that a voter or an adult given that an adult prefers the Republican Party, what's the chance that the adult is a woman? Well, the chance is 46.9%. All right, so lurking variables may, so this is the last topic here. The lurking variables may influence the relationship between two categorical variables as well. So we have this Simpson's paradox, and this is I am writing this exactly as it is in your textbook. An association or comparison that holds for all of several groups can reverse direction when the data are combined to form a single group. That is the relationship that you might see in each of several groups of data. When you combine them into one big group, that relationship might reverse direction. And I'm going to give you an example here. So let's say we are comparing two hospitals, hospital A and B. And so we have two variables here. One is hospital. So hospital has two values, hospital A and hospital B. And then the other variable is the survival of patients. So the values for this variable would be died or survived. There are two values. So let's say that that these are here are the counts for each of the cells. So 63 of the patients in hospital A died. 16 of the patients in hospital B died. 2,037 of the patients in hospital A survived. 784 patients in hospital B survived. So this is the 2,100 is the total number of patients in hospital A, and 800 is the total number of patients in hospital B. And here in the last row, I'm writing down what percent of patients survived in each of the hospitals. So notice that 97% of the patients in hospital A survived, and 98% of the patients in hospital B survived. So which hospital has better survival rate? Well, looks like hospital B. Well, so that looks reasonable until you see this. So now I am dividing the data into two groups. So one group with patients in good condition and the other group with patients in poor condition. So in hospital A, 6 patients in good condition died. In hospital B, 8 patients in good condition died, right? And in hospital A, 594 patients in good condition survived, and hospital B, 592 patients in good condition survived. Now in the second table, if you look at 57 here, 57 means 57 patients in hospital A, 57 patients were in poor condition and died. In hospital B, 8 patients were in poor condition and died. In hospital A, 1,443 patients who were in poor condition survived. In hospital B, 192 patients who were in poor condition survived. Okay, so these are the total in each of the hospitals, and these are the survival rates. So now notice that the survival rates, so here, how did I get the survival rates in the first table? Well, the count for survival, the count for, so 594 is the count of patients who survived. So you divide that by the total number of patients in hospital A. So 594 divided by 600, that's 99%. Similarly, 592 over 600, that's 98.7%. And we did the same thing in the second table. So once we separate the patients into two groups, now we see that hospital A's survival rate is a little bit better than hospital B's survival rate. So again, here I didn't divide the patients into I didn't divide the patients according as poor versus good condition, and when without dividing the patients into two groups, we see that hospital B has a better survival rate. But if we divide the patients into two groups according as poor or good condition, then we see that the relationship reverses. That is, now hospital A seems to have better survival rate. Okay, so this is what is known as the Simpson's paradox. All right, so that's it. That is all I want to say on this last section of chapter 2. And I hope you understood most of it. If you have any questions, of course, you can ask me when we meet. Until then, I hope to see you in the next video.